Welcome to another installment of the Omnis on-demand training series, Omnis Studio Web Development Basics. In this part, we take a look at the different variable types in Omnis Studio and what they are used for. Have fun! In the previous video, we already looked at variable scopes and explained how to define a variable. However, we left one important part open: the variable types and the corresponding subtypes. A quick note: the variable types are nothing else but the normal data types in Omnis Studio, just related to variables. Variable types, together with their subtypes, specify what can be stored in an Omnis Studio variable. For example, whether it is a character string, simply put, a text, whether it's integers, decimal numbers, and so on. Each variable type has got its own specific advantages. For example, the integer, which allows you to calculate with numbers, or the date format, which in turn enables you to calculate with dates. But more about that in a moment. Let's first clarify which variable types there are and where you can define the type of a variable. So, to do this, I'm back in our sample library that you already know, and I could go to the class in which we want to edit the variables. However, in this case, I'll create a completely new form and call it variables. And as I don't have a defined variable here yet for which I could set the type, I'll just create a new one. And I'll call it iCharacter. So, up to this point, we knew all this already, and we also learned that if I now leave the name field of the variable here, the variable is automatically defined as the type character. We can see this here in this column, and this is exactly the place where we can now define the variable type. As I said, the default variable type is character. However, if we want to change the type, we can go to this drop list and simply select a different variable type from the quite long list of variable types. But it would be too much to describe every single variable type in this video. I'll better explain each new variable type when we will use it for the first time. For today, let's take a look at the 5 basic variable types in Omnis Studio, which are the types character, integer, number, Boolean, and date time. To do this, I first create a variable for each type. We already have got one for the type character, but not for the type integer. So here is a new line, iInteger, of the variable type integer. Next, another new line, iNumber, of the type number. Then, iBoolean, of type Boolean. And finally, iDateTime, of type iDateTime. Well, I think some of you may know something about these data types already, but I will explain them a bit for everybody, especially since each type also offers other subtypes. Okay, due to the type, we can now store a chain of characters, in other words, a string, in the variable of type character. So, this variable type is therefore particularly suitable for storing text, names, email addresses, etc. And with the character type, the subtype specifies the maximum length of this string. In the default case, this is 100 million characters. As a variable of type integer, we can only store integral numbers, i.e. numbers without decimal places. Different from a character variable, in an integer, it's not the character string that is stored, but the value. This is important when you want to set up mathematical conditions with these variables, for example. The subtype of the integer then specifies the maximum memory size, except here, the short integer only allows values from 0 to 255. The number type is similar to integer, but number also allows decimal places, and its subtype then determines how many. By default, number variables are defined with the subtype floating DP. This simply means that Omnis accepts the decimal places as those of the assigned value. If you now assign a value of 10.321 to iNumber, the variable stores exactly this number with the 3 decimal places. However, if I select 2dp here, then only 2 decimal places are accepted. The next variable type here is Boolean, which I think is the simplest. This is because a Boolean value can only be 1 or 0. This will then be interpreted in the program code as true or false, for example. And as this type is already very specific, there is not even a subtype for it. However, things get a little more complicated now with the date-time type. As the name suggests, this is for storing dates and times. The subtype then determines the format. The subtype here, date time dmyhns.s, for example, then stores according to the letters D, the day, M, the month, Y, the year, H, the hours, N, the minutes, and S.S, the seconds including fractional seconds. Most of the other subtypes are then composed according to these letters. However, there are a few exceptions, which are these 5 subtypes: short date 1900, 1999, short date 1980, 2079, 2000, 2099, short time, and date time in brackets #FDT. The top 3 are each limitations of the time period to the specified years. Short time simply stores the time, but in hours and minutes, and date time, in brackets #FDT, is a date format that was previously defined in the hash variable #FDT. But I won't go into more detail about this now. Alright, that was a lot of text again. I would suggest we now take a look at this in our new remote form. I don't need to define the variables for this, as we've just done this while we learned about the variable types. So let's go to the design editor. By the way, from the method editor, you can access the design editor of the remote form by pressing F3. I'm going to drag 2 entry fields in here. 1, 2. And to demonstrate how it works, I'll link the first field here to the character variable, and the second field to the integer variable. So, if we now try to use these fields to write an unauthorized value in one of the variables, then this should ideally not be possible at all. In our case, this is particularly the case with the integer field. After all, we should be able to enter almost anything in the character field. Well, let's test that. We have the character variable in the first field, so I'm able to enter all sorts of things here. For example, hello Omnis 12345. Right. In the second field, however, we have the integer variable, so if I try to enter the same as in the character field, yes, we get 12345, just without the comma, because only digits, or more precisely, integers, are allowed here, so no decimal places either. I can't. Unfortunately, you can't see it, but I can't even type in a comma here. Yes, marvelous. That's it for today. I know it was a lot of theory, but not so much practice, but that will come right in the next video, where we'll look at how you can create your own methods with your own logic. Hope to see you then. Take care.